Okay. Well, thank you guys for coming to our week 13 general meeting, and thank you for our non-RIT folks as well. We really appreciate having you guys here. So I wanted to talk about this article. They were basically talking about how climate change is affecting coral in the Red Sea. And basically coral is very temperature sensitive. And for the most part, coral has been having a lot of issues with rising temperatures. Very slight temperature changes will cause lots of issues in the coral. But these scientists were studying a specific area in the Red Sea where coral has a much higher upper temperature limit. They're much more resistant to temperature change. So they were doing testing on this, and they found that this coral had adapted to these higher temperatures. But now if the temperature drops like a single degree Celsius, that would cause something called bleaching of the coral, which is, I couldn't explain it super well, but basically it doesn't allow the coral to absorb energy. And they were saying that this is an issue because, I mean, obviously climate change is not just global warming, it's global weather changes, it's more erratic weather. So there is a higher chance of much warmer and also much cooler. So they were kind of pointing this out as an issue for this potential refuge, they referred to it as, for coral. Overall, though, I would say, like, this article kind of posed this as a bad thing, which it kind of obviously is. But I would view it as a positive thing because this coral was kind of outside of the norm of all the other species of coral. So we keep finding kind of differences to the rule, exceptions to the rule. So it was kind of interesting that if we're finding a coral that works this way, we'll find a coral that works this way. So with all this information, we can hopefully find a solution. I thought this was pretty interesting. Also, this picture is just gorgeous, and I thought that was really cool. But yeah, moving on. I want to mention 2 events coming up this week. And then we're going to get onto our 3x5s. So the first is that either it'll be in the breezeway between the SAU and the Clark Gym, or it'll be in the SG office or in that area around the fountain. There is going to be a plant giveaway that's hosted by SG Sustainability Committee. And yeah, so they are asking people to sign up on campus groups for that. I don't think you really need to. You can probably just walk by and grab it. But yeah, that'll be on Wednesday afternoon. The other thing I wanted to mention is, I think I mentioned this last week, but SG is also putting on this Lights Out event. This is going to be Wednesday night, right before, so Earth Day is the 22nd, Thursday, which is our recharge day, and they want to do the evening before that. They want to do an Earth Hour, so it'll be from 8 to 9 p.m. They are hoping to get as many people as possible to just turn their lights off for an hour, use as little energy as possible. And they're going to be taking energy readings of the dorm buildings during that hour to see how much the power drops. So if we have anyone in here living in dorms, I would definitely encourage you to take part in that. And I would definitely encourage you to tell your friends about this as well. I'm not sure how much marketing they've done on this, but yeah, I think it should be a really cool event. Okay. Oh, Shreya says there's a make your own succulent event as well. That's kind of cool. Did not know about that. Do you know what day that is, Shreya?
Yeah, that's tomorrow.
Oh,
It's for commuters only, but if you have a commuter friend that's not going, you could try to register.
nice. I might do that. I have too many succulents, but I need more. Okay, yeah, so the 3x5s, this is going to be the order of them. You guys know the drill, you know how this works. And we're going to get right into it. So water filtration, you guys are up first.
Okay, hi, so this is the project for water filtration. Next slide. So basically a brief overview I went over last time as well. We're partnered with TAM Ceramics to create a water filter suitable for household use. The desired flow rate is 2 liters per hour, and we want the consumer product to be ultimately less than $10. The TAM Ceramics gives us the filter media, and the company itself is promoting safe drinking water in nations that necessarily don't really have that resource. Next slide. So progress so far is that we've finalized an initial design that we're using. I managed to actually get to the storage unit and get some of the materials we had last semester, which is the middle picture. And I'm in the progress of waiting for some materials to arrive to do some more testing. The picture on the right is a method to hold the filter media, which is the bag right there, to contain it and be able to filter water out. And the picture on the left is the mesh screen that we're going to purchase. Next slide. Finally, some goals that are that hopefully maybe start fabrication of some type if we receive the materials in time. And there's another possible design that we can look into, which is the picture on the left that one of the stakeholders suggested. But for now, we're going to stick with the design on the right first and see how it goes. That's it. Any questions?
Yeah, I did want to ask, and I'm going to go back a slide. What is your, oh, I was going to ask, what's the sizing of your mesh? Because that looks pretty darn small.
Yeah, it's 120. It's really small. The stakeholders specified that it had to be 100 mesh or less. And then the nearest one we could find was 120. 100 mesh they then sell, and we couldn't do anything like 90 mesh and stuff, or else the filter media would be leaked through.
What's the unit on that?
The unit?
Yeah.
Like how it's measured?
Yeah, what's that 120 what?
120, it's like inches per the holes, how much it filters through.
Gotcha. Okay. Nice. Any other questions?
Yeah, could you just give a comparison of how fine the filtration powder is, just for kind of a reference for those not familiar with the project?
Okay, so the filter media is pretty fine. So if I say like this is it needs to filter through on 100 mesh, then the media itself is around 95 to 98 mesh. So we needed something larger than that. So basically, I guess the best comparison from looking at the picture in the bag is similar to sand, but a bit the material is slightly bigger.
Awesome. Any other questions? All right, great. Thank you, Vicki.
You're welcome.
Next up is going to be InselNest.
Hello, can you hear me all right?
Yep, you're good.
All right, cool. Hey guys, InselNest, I think I'm the only one who's here that's on the team. Anyways, so if you're unfamiliar with the project, we are trying to make sustainable organic building thermal insulation material. So the current iteration of the project is focusing on mycelium, which is the root structure of mushrooms. So with mycelium, you can basically, it's a bit of like a network of mushroom, basically fiber growing and bonding whatever your substrate is. And in this case, we're using hemp pulp. So as you can see on the, like in the middle, towards the bottom, that's one of our samples. So on the right, you can see we were processing one of our samples. So we tried to light it on fire, that because it's organic, it does tend to burn a little bit more easily than things like fiberglass. So we try to light it on fire. It doesn't want to burn. Okay, so it sort of self-extinguishes, but it still would char. We actually also try to laser cut it, so it would char and it would smoke. So a little bit room for improvement there. So we ended up just band sawing the edges off to make a uniform rectangular shape for testing. So the whole point of the meme in the middle is so that we're not making cotton candy instead of because usually these type of insulation are unsustainable because can you go to the next slide, there should be animation. Yeah, so for foam insulation, the production of that usually involves some sort of a chemical extraction, a lot of energy input to melt the glass, form the glass into conventional insulation like fiberglass you see. But with mycelium insulation, you only need an agricultural process, right, and a combination of some agricultural waste in which, I mean, in this case, hemp pulp is an agricultural waste, so it's virtually free to get. And you combine them, you heat treat it to harden it, and that's how you have mushroom village. Next slide. All right, so we wanted to figure out the thermal conductivity of our material, of our sample, to really figure out how good it is as an insulation material. So on the left, you can sort of see this theory, the derived formula for the thermal conductivity as a function of the heat rate, thickness of the material, the area of that material, and the temperature change. Okay, so the picture in the middle is our team, part of our team, and then our actual setup, which is the physical execution of this schematic on the right. So heat flows from hot to cold. So in this case, from the hot plate, which is 100 degrees, to the cold water, which is roughly at like 20. So we just waited for everything to reach steady state, so we can have a one-dimensional steady state thermal resistance analysis. It sounds more complicated than it is. So the math is kind of simple. So we were able to back out the thermal conductivity of our material with the help of a reference material with a known resistance value. So in this case, it's foam board, which has a thermal conductivity of pretty much like the same as air. So the thermal conductivity of our material is about 0.03, almost exactly 0.03. So how good is that? So for reference, could you go to the next slide? For reference, a lot of the insulation materials on the market have a thermal conductivity of 0.04, more or less. So this is to say that our material actually performs better than a lot of the stuff out there, but our material sort of, it costs under $20 to make. So instead of a whole factory, it can be made pretty much in a DIY setting. So the cheapness of that, the ease of production makes us stand out in applications like warmer countries with not as much economic power to mass produce foam insulation or like the chemical sort of insulation. They can have that, or countries where buildings are knocked down by natural disasters a lot. So because of that cheapness of the production, you can replace your foam insulation with this type of material, which is, although it's not as fire retardant, it is a lot cheaper to make, and it's a lot better than for the environment. So we did a little bit of analysis to figure out, what if we can add an air pocket to it, and modeling the air pocket as basically a solid, and using the thermal conductivity of air, assuming that there's no convection. Now, of course, convection is going to kick in the bigger the air pocket sort of grows. So we're going to try to figure out a way to limit convection so we can have an optimal air pocket thickness. And some of our designs are on the bottom there. You can have it's a lot of industrial design. You can have air pockets in different ways, and sort of the modular design with how different modules of mycelium insulation can sit on top of each other and create those air pockets on a macro scale. So one of our next steps is modeling different air pocket designs. So we are always looking for new designs, by the way. So if you have any ideas, talk to me, please. Okay, so secondly, we want to make samples with smaller particle size. Because the samples were pretty flaky, decreasing the particle size can make it, more homogeneous and hopefully less flaky to deal with. Okay, so we're going to need a blender for that again. Okay, so just a couple more points there. We do want to repeat the conductivity experiment that I just talked about with new samples, just to validate everything. And then last but not least, we want to make more samples. So with our optimized air pocket design. So yeah, any questions?
I wanted to ask, I think it's kind of interesting how just looking at like the long-term path that this project has gone on. This started out mainly as a geometry focus, and I'm kind of curious how you guys got from geometry focus to more material focus, and now you're kind of adding back in the geometry aspect of it.
Yeah, it's kind of like coming back to a full circle, because material science is like the #1 thing with this. We are making an insulation material. So material is going to drive your material property, right? It's going to drive your thermal conductivity. So that's really important. So a lot of heat transfer.
So I guess with that, are you looking at that initial like wasp nest insulation type geometry for some of your air pocket designs?
I mean, they kind of look like the nest geometry, some of them like #1 and 2 maybe. So some of them might look like them, but like it's not completely mimicking the form of the wasp nest anymore, because the wasp nest, although we can conclude that it's for insulation, but it also could be that it's just easier to build like that, layer by layer. So it just uses less material. So you can sort of think about it like the more air pocket we have, or the thicker the air pocket we have, the less material we actually need to have theoretically a better insulation material, assuming we're not considering like convection, which we're trying to limit.
Any other questions for Jimmy? All right, awesome. Thank you, Jimmy. We are going to move on. Next, we have our U of R project. Thank you guys for coming tonight.
Hey, thanks for having us. So yeah, this is the University of Rochester Solar Decathlon Design Challenge presentation. I'm Avni, a U of R student, and I'm joined by Humphrey Kimani, another U of R student and team member. So our design is You Are Home, and we partnered with Habitat for Humanity International and our local chapter in Rochester, Flower City Habitat for Humanity, to modify one of the standard designs into You Are Home. Next slide, please.
Yeah, so we first had to determine the target market, and it lies at Josana neighborhood. That's how Flower City Habitat often builds homes. So we designed a 4-bedroom house, which is intended for up to 5 occupants. And during the design, our main goals were simplicity, affordability, and sustainability and energy efficiency. So simplicity in the sense that we had to make sure that the design can be built by the volunteers, because the partner that we have, Habitat for Humanity, Flower City Habitat, normally deals with volunteers building everything from scratch. So we basically wanted to make that as simple as possible, and that all rooms and male living areas should be designed with a lot of space so that wheelchairs can move freely. And secondly, with regards to affordability, we had a ceiling price set by Habitat for Humanity, which was $120,000. And so basically we had to make sure that everything that we sort of purchase or analyze in the market area has to reach that much or be less than it. And finally, with regards to sustainability, in conjunction to affordability, we had to make sure that the products that you're gonna choose for every particular aspect, say foundation, roofing materials and all that, have to be sustainable. So they have to meet the goals set by UR Solar Decathlon, and also be optimizable so that they can perform better with more energy efficiency. So we employed a decision matrix to help us pick the most sustainable materials for those parameters.
Yeah, and so Habitat prioritizes accessibility. And so we wanted to ensure that UR Home was accessible for wheelchair users. We implemented an open floor design with sliding doors and a roll-in shower for accessibility. The roll-in shower is like at the bottom right corner. One of the main design changes we made was moving the bathrooms to the lower right corner here. The original design had hot water fixtures spread throughout the house, and by moving the bathrooms closer to the hot water heater, we minimized the heat losses associated with the water traveling to the fixtures, which are like spread throughout the house, and therefore minimize the energy demand of the home. Next slide.
Next slide. So to conclude, UR Home gave a HERS score of around 40 without the renewable energy system, and 10 with an on-site solar system. Primarily, our design had a community-based solar idea in mind. However, based on the fact that we used Ecotrop software and that parameter cannot be embedded in it, we just had to use on-site solar, and that gave us a higher score of 10. So we anticipate the score could be much lesser than that because community-based solar has proven to be even more effective than on-site solar. And UR Home is also below a maximum budget of $120,000 US. And we got actually overall cost of building the house to be $109,000 US. So it remains to be simple and feasible for Habitat to build, as well as accessible, with 4 wheelchair accessible bedrooms, a roll-in shower, and an open floor design. Thank you for your time. And would like to welcome any questions.
I was curious, what features were you responsible for designing on this? I know you mentioned like the bathroom to the water heater. I'm just curious, like how much of a full working house were you responsible for designing?
Yeah, so the way we went about this was that we partnered with Habitat for Humanity, and we just offered to take one of their standard designs and just make it more energy efficient, more sustainable, like with more sustainable materials, and to minimize the cost as much as we could. So the original design we got from like a Habitat branch in Connecticut. And so we just got like the whole like base design. And so we tried to make changes wherever we could to decrease the cost and make it more energy efficient. So like one of the changes was like flipping the design across its axis, improved like some passive solar heat gains during the winter and some other stuff, and like moving the rooms around, then changing the insulation in the walls and the roof and stuff like that. So there was no like one particular like aspect. It was sort of wherever we could make improvements to the design.
Yeah, and to top on that, we had more space outside. I mean, the slide doesn't show here, but there is extra space that we also added a food garden. We designed that one. So it kind of helps in terms of trying to reduce as much waste or anything that doesn't, agree with sustainability. So everything is grown the garden during the good seasons, and then yeah.
Nice. Any other questions? All
shout
right,
out
if not, oh,
RIT.
sorry.
That's right. I was gonna shout out to the RIT, Solar Decathlon design. That was really cool. We saw them at the event. They were in another division though. They were in attached housing. And that was like a really cool design as well.
Nice. Yeah, we were proposed this project. I don't think anyone was super into it from our club, but yeah, I know someone was working on it. That's pretty cool. Is this an annual competition?
Yeah, so the Solar Decathlon has two sub competitions. One is the design challenge, and that's just designing, and it's yearly. And the other one is the build challenge, where you design and actually build the house. And I think that is every like 3 years.
Oh, that's awesome. Have you guys ever done one, or would you be interested in doing one of the build challenges?
So this is our first Solar Decathlon, and we're in the design challenge. So we at the moment don't plan on doing any like further design or build challenges, but it's always an opportunity. The door is definitely like open to like collaborate between our chapters if we like choose to go down that route in the future. That would be really awesome.
Yeah, that would be super cool. Awesome. All right. Thank you guys. I am going to move on to our next presentation, which is Arborloo.
Hi guys. I don't know what's going on with my font there, but that's okay. I'm Renee. I'm the project leader for Haiti Arborloo, and I'm going to tell you some updates that we have with it. So basically, we created this sustainable, affordable, collapsible latrine system for rural parts of Haiti, so that we don't have to build something that withstands natural disasters. We have something that can avoid natural disasters, basically. So right now there's a problem there where the systems that they currently have are being destroyed by natural disasters, and it's too expensive to rebuild them afterwards. So this is our solution that we've come up with here. So right now we're working on some concrete testing still. We did set up a lot of molds at the end of last semester with hopes that we would be able to test out those different compositions that we were using this semester. But it turns out that they didn't set correctly when we pulled them out from the lab. So we still need to get some new testing materials in order to test them again and find a time that works for everyone. So we're kind of on a pause with this one right now. And then our other part of the project that we're working on is trying to have the prototype designed in Haiti. So we got it all approved with our contact in Haiti, but now we're just trying to figure out how we can send the money there and have it allocated towards this prototype being built there with the materials there. So we're still trying to figure out the communication side of things and what RIT is actually going to allow us to do to get the money over there. So that's where we're at right now.
I don't know if you saw it today, but Peter and Sarah and I were talking, and we're definitely getting closer to having that money transferred.
Okay, perfect.
Any questions?
Okay.
Actually, I want to go back and look.
Go for it.
Oops. Do you guys have, so I don't see the door here. I know you guys have done that though. I'm curious about like the hook. I don't know. Can you see my mouse?
Yes, yeah, I can.
I'm curious how you did the hook, what material that is going to be made out of.
So we figured out a way that we could make it out of bamboo for the design in Haiti, but for the design that we have, like the prototype that we built here, I believe we just used a metal S hook, and we were able to drill it into the PVC, and then we were either able, I think we put like an eyelet into the other side of things because we couldn't drill into the PVC the way that we wanted to. So that's how we're compensating for it with our materials here.
Gotcha. All right, any other questions?
Okay,
All
thank
right.
you.
Yeah, thank you, Renee. And we are going to move on to Red Creek. I don't know if this is Kylie or Miles.
Kylie's not here, so I'll be presenting. So the background for our project is the Red Creek runoff behind K-Lot, which is a lot for students behind residence halls. And it basically gets polluted by cars parking there and like road salt that gets put in the lot as well. So we're trying to find ways of reducing the pollutants that get into the Red Creek. So currently we're researching bioswales and roadside alternatives, and recently we've compiled a basic list of supplies for like each layer of the bioswale, which consists of like native plants to Rochester, types of mulch that we could use, soil, gravel, piping, and drywall, and like costs and alternatives for those. And I took some videos and pictures of some bioswales that are already up near UC for like stuff to build off of, and like we could use that for inspiration. And then the road salt alternatives, we found over 5 alternatives, and we're working on narrowing down the top 3. And moving forward, we want to finalize our research of the bioswales and continue to research the top 3 alternatives for the salt, like really break down the cost for time and money of those, and then contact the groundskeepers to inquire about like the bioswale installations near like at Perkins as well. So that would be of interest to us.
I'm curious, do you know, you were talking about road salt issues. Do you know like what is the biggest issue with road salt in the water? Do you know what that actually causes?
I think it just like probably changes like the pH in the water. I don't know though. I'm not working on that. But it definitely changes something about the water that's bad, because there's probably something in the road salt that like is not natural.
If I remember correctly, it mixes with the algae and breaks down like the existing like plants in the water. And it just generally is poisonous to animals.
Thanks. That sounds about right. Yeah.
Any other questions? All right, then we are going to move on. Thank you, Miles. Okay. Oh, next up is me, actually. So yeah, I'm gonna update you guys on what we've been talking about. So just as a reminder of the background of our project, we are building a rainwater catchment system to provide water to a community garden of a nonprofit in the dry season. The requirements are it must have a maximum square footage of 100 square feet. We want it to be protected from pests like mosquitoes, and we don't want this to be a permanent structure. We need to be able to disassemble this pretty easily. And our end deliverables are solid project documentation and assembly instructions for the University of Hawaii students. So some updates, and Catherine, if you want to jump in at any point, feel free if I miss anything. But we added a couple things. We added a support plywood to the base there. That middle piece of wood was not there before, and we wanted to add that just to hold up the other planks. We went from 3 plywood panels to 2 panels as the base there. We also decided on the corners on the ends of these pillars. Before we had 6-inch wood screws keeping those together, and we decided to go forward with carriage bolts instead. We felt that would be easier to for assembly and disassembly, because you just pull out quite a few carriage bolts, but you just pull them out and you have a separate base and roof pieces, and then you have these 4 pillars, and it would be relatively easy to take down. We are also changing a couple things on the roofing. We added the supports for the roofing panels. And I don't think I wrote this in, but our customer requested that we shorten it a bit, because they've had issues with people just coming and taking stuff. So they wanted to make sure this was not visible from the nearby road. So I think we took a whole foot off of the height. Did I miss anything, Catherine?
No, those are the main points. We brought the general frame of the roof in. It just gives better support to our outer pillars. If that is holding from the inside, it reduces the torque, especially since we're dealing with high winds. Having that support from the inside will be extremely beneficial. It also just makes it easier to disassemble and brings down our height based on those 2x4s. In addition, we are also requested by customer to add additional supports to the roof that align with the corrugation. That those aren't shown in the CAD here, but they'll go along those 2x4s and match the corrugation of the roof.
Yeah, so just overall, for our final deliverable updates, our BOM in progress, our cost dropped. This was pretty amazing. Our cost dropped from about $600 to about $430, which we are quite happy about, seeing as our maximum was $500. And this was, a lot of that was legitimately just from kind of reorganizing and reallocating our wood, which was kind of nice. Our assembly document is in progress. It's kind of interesting. We're finding a couple issues now in writing that assembly document where you're like, oh, okay, so we have a good design, but it's not physically buildable. Well, it's not easily physically buildable. So we found some issues like that. But our build day in Hawaii is scheduled for May 17th, I believe, which is very exciting. And I think we're all pretty psyched to see this actually be built after working on it for a couple months. So that's exciting. And supporting another chapter.
Yeah, I think it's definitely brought to light how in tune you can be with a project, and then trying to explain it to other people when you're not going to be there for build day. I know Arborloo has absolutely run into this. I mean, there's the additional language barrier there, but you have to be very precise with all of this, and it's easy when you're going through it in your own mind or talking to your teammates to breeze over things that aren't as intuitive to others.
Yeah, attach part number 750 to 1.36 inches away from the end of part 56. Yeah, it's a little, yeah. But it's happening. Anyone have any questions for us? Okay. That is the last one we had for tonight. If anyone wants to see this later, it will be on YouTube. Don't forget about those events. Tomorrow you can get free things. Why would you, that's easy to not forget about, free things, plants. Yeah, and I hope everybody has a good Earth Day on Thursday, and kind of more importantly, a good recharge day. I hope you actually get to recharge or catch up. Okay.
Thanks
Everybody,
again, you are.
yeah, absolutely. Thank you guys for coming, and I hope we get to continue collaborating in the future.
Yeah, thanks for having us. This is definitely a cool event and looking forward to that as well.
Awesome. All right. Bye, guys.
Hey, Sarah. Very slow.